There is a planet at the very edge of our solar system that, according to the laws of physics, as we understand them, should not be where it is. It's called Sedna. It's about the size of a small moon. It's colder than almost anything we've ever found. And right now, for the first time in over 11,000 years, it is coming back toward the sun. The last time Sedna was this close, the last ice age was ending and human beings were just learning to farm. It won't happen again until the year 13,000, and the strangest part isn't where Sedna is going, it's how it got out there in the first place, because nothing in the known solar system is powerful enough to have put it there. To understand why Sedna is a problem, you need one number. Every object in the solar system orbits the sun in a loop. For the planets, those loops are nearly circular. Even for distant, icy objects out past Neptune, the loops follow rules. They get flung outward by Neptune's gravity, then swing back toward it. That's how the outer solar system works. Sedna doesn't obey that. At its closest, Sedna comes to about 76 times farther from the sun than Earth. That's its nearest point, and it's still almost 3 times farther out than Neptune. At its farthest, it travels to nearly 937 times the Earth-Sun distance, out into the cold and the dark, and then it turns around and comes back. One full loop takes roughly 11,400 years. But here's the part that stopped astronomers cold when Mike Brown and his team discovered it in 2003. Sedna never comes close enough to Neptune for Neptune to be responsible for that orbit, which raises a question nobody has fully answered in over 20 years. If Neptune didn't put Sedna out there, what did? Before we get to that, there's a reason this matters right now in our lifetime. Sedna spends almost all of its 11,000-year orbit impossibly far away, invisible, frozen at temperatures that never rise above minus 240 degrees Celsius. We only discovered it at all because we happened to catch it on the one tiny stretch of its journey when it's close enough to see. And it's about to reach the closest point it gets, its perihelion, around the year 2076. After that, it begins the 11,000-year fall back into darkness. The next time it returns, no one alive today, and likely no civilization we would recognize, will be here to see it. We are the only humans who will ever get this particular chance to study it up close, which is exactly why what we don't understand about it is so frustrating. Quick one while that sinks in. If you're enjoying this kind of deep space mystery, consider subscribing. I break down the strangest discoveries in our universe in a way that actually makes sense. Now, what put Sedna out there? Because the leading explanation is something we have never actually seen. When Brown, Trujillo, and Rabinowitz announced Sedna in 2004, they were direct about the problem in their own paper. Sedna's orbit, they wrote, could only be explained by the gravitational influence of an external object, something beyond the known planets. They laid out the possibilities. The first, a passing star. In the chaos of the early solar system, when the sun was still surrounded by sibling stars in its birth cluster, one of them could have passed close enough to gravitationally tug Sedna into its detached orbit, then drifted away forever. Plausible, but unprovable. That star, if it existed, is long gone. The second possibility was stranger, that Sedna didn't form in our solar system at all, that it was captured from another star's system during a close encounter, making it, in effect, an interstellar object that never left. And the third possibility is the one that has obsessed astronomers ever since, that something is still out there, a planet, large, distant, unseen, whose gravity reached out and pulled Sedna into place, and which is still orbiting the sun in the dark right now. For years, that was just one idea among several. Then, in 2014, a second object was found, 2012 VP113, discovered by Chad Trujillo and Scott Shepard, another detached world on a Sedna-like orbit. And it shared something with Sedna that it shouldn't have. Its orbit was tilted and oriented the same way. Two objects, impossibly far out, both detached from Neptune, both pointing the same direction. That's not the kind of thing that happens by chance. And in 2016, two scientists at Caltech ran the numbers on what it would take to line them up like that. The answer was a planet the size of a world we lost. Genuine question before we go further: if there really is a ninth planet out there, why do you think we haven't found it yet after 10 years of looking? Drop your theory in the comments. Some of them are going to be better than you think. Here's where it stops being a story about one weird object and becomes a story about a missing planet. Because the same math that explains Sedna predicted something else entirely. And then that something was found. In 2016, Konstantin Batygin and Mike Brown, the same Brown who discovered Sedna, published a study in the Astronomical Journal proposing a solution. Their model? A real ninth planet, far beyond Pluto, roughly 10 times the mass of Earth, orbiting the Sun at a staggering distance, hundreds of times farther than Earth, on a loop that takes between 10 and 20,000 years to complete. In their simulations, a planet exactly like that did something remarkable. Take an ordinary object from out past Neptune, and the gravity of this hidden planet would slowly pull it away, detaching it from Neptune, lifting its orbit, producing a world that behaves exactly like Sedna. The hypothetical planet didn't just explain Sedna, it explained the whole cluster of detached objects, all at once. But the model made a prediction Brown didn't expect. It said there should be another group of objects out there, ones forced into orbits at right angles to the rest of the solar system, perpendicular, objects nobody had any reason to look for. When Brown checked the existing data, those objects were already there, 5 of them on exactly the perpendicular paths the simulation demanded. In his own words, his jaw hit the floor. A model built to explain Sedna had predicted a completely separate set of objects, and reality matched it. That's the kind of thing that, in science, usually means you're onto something real. And yet, 10 years later, no one has seen Planet 9. Not because the idea is dead, but because the search is brutally hard. We don't know exactly where it is. It would be extraordinarily faint, and the sky is enormous. Absence of a photograph isn't absence of a planet. But it has opened the door to a competing explanation. In 2018, a team at the University of Colorado proposed that you don't need a hidden planet at all, that the combined gravity of thousands of smaller objects out there, acting together over millions of years, could push worlds like Sedna into detached orbits on their own. No ninth planet, just the quiet, collective pull of everything we haven't counted yet. Both explanations are still on the table, which means the honest answer to what put Sedna out there is the one scientists hate to say out loud: we genuinely don't know yet. In 2017, after 13 years at Saturn, Cassini flew itself into the planet. Gone in under a minute, NASA destroyed it on purpose. It couldn't risk crashing into Enceladus or Titan and contaminating a world that might hold life. So, the spacecraft that found the best signs of life in the outer solar system was killed to protect the life it might have found. The rings will be gone in 100 million years. The moon that made them died 160 million years ago. And we happened to be here, alive, looking for the one brief moment when all of it was still visible. That's either the luckiest coincidence in astronomy, or it's exactly what you miss if you stop looking up. Subscribe for the next break in this story, and go watch the Triton video next, the ocean moon NASA refused to visit before the window closes in 2030. It's up now.